My name is Dr. Esther Trufan, and in this video, we will be exploring some chemical reactions. In the course of chemical reactions, there are a lot of processes that could potentially happen, and in that context, it is important to distinguish between the different types of reactions that we're observing. The first type of chemical reaction is a decomposition reaction. That is where we start with one compound, usually compound, and in the course of a process, either through heating or some kind of other method, we're able to separate it into some of its ingredients. One example of a decomposition reaction is sodium bicarbonate, which is a white solid. If we apply heat to it, which I will indicate with delta, it will decompose to produce sodium carbonate, which is another white powder. It will release carbon dioxide in the form of gas. And under those temperature conditions, it will also produce water vapor, which will exit the reaction container. If we are to balance this chemical equation, the only thing we would have to do is put a 2 in front of the sodium bicarbonate. Combination reactions are those where we start with two substances, and those two will combine to form just one product. There are many reactions that do this. One of the flashiest ones is the reaction of magnesium with oxygen. Magnesium is a silver gray solid, and when burnt in air or in pure oxygen, which is a gas, it will produce a bright flash, and the result will be a white powder, which is the magnesium oxide. Magnesium oxide is a solid. To balance this equation, we need to place a 2 in front of magnesium and a 2 in front of the magnesium oxide. There are combustion reactions that require a fuel and an oxidizer. Probably the most exciting one of the combustion reactions is the one where we burn hydrogen. Hydrogen gas reacts with oxygen gas to produce water in a flash of fire. And under those conditions, the water is going to be vapor because it produces a lot of heat. To balance this equation, we will place a 2 in front of the hydrogen and a 2 in front of the water. Double displacement reactions are often called double replacement or metathesis reactions. These involve the exchange of partners between two substances, very often two ionic compounds. The most common example will be found in precipitation reactions. So one example could be the reaction between sodium carbonate, which is soluble in water, so we mark it as aqueous, and calcium chloride, which is also soluble in water, so we mark it as aqueous. The result of the double displacement or the partner exchange is going to be the production of sodium chloride, which is soluble in water, so it will be marked aqueous, and calcium carbonate, which is a precipitate, and we indicate it as solid, which comes out of the solution in which the sodium chloride is dissolved. To balance this equation, we will place a 2 in front of the sodium chloride. Single displacement reactions are the reactions in which an element is reacting with an ionic compound, and in those cases, the element replaces one of the ingredients in the compound. One common example for this is the reaction of magnesium with hydrochloric acid, and you probably conducted this experiment in the gas laws lab. When these two react, the magnesium and the hydrogen will exchange, producing magnesium chloride, which is aqueous, and hydrogen, which is a gas. Magnesium by itself is a solid, and hydrochloric acid is usually found as an aqueous solution in the lab. To balance this equation, we will put a 2 in front of the hydrochloric acid, and with that, all the atoms are accounted for on the two sides of the equation.